Hey guys, we are going to refresh of how to solve quadratics by taking square roots and factoring. I thought I'd go ahead and make a video of just 3 quick examples. We just got off a 2-week spring break, long enough for you guys to forget everything, that this way there were fresh notes for you guys to look at. Since this is review, I'm going to go through it kind of fast, but it's a video. Pause it, rewatch any parts that you need to. Our first example, we're going to take a look at square roots first. Remember guys, our goal for square roots, work pen, is to get stuff squared equal to a number. All of this is my stuff that's in the parentheses right now. I have nothing outside the parentheses, nothing that's not getting squared. This is perfect because what that means is I can go ahead and take the square root of both sides. That's going to leave me with 2x minus 1 is equal to not just a positive 3, but also a negative 3. So I'm going to write it as plus minus 3. This isn't good enough though. We want to know what x is. So I'm going to go ahead and I'm going to split this up into 2 different problems. I could have 2x minus 1 is equal to a positive 3, or we could have 2x minus 1 is equal to a negative 3. I'm going to go through and just quickly solve for x, trying to figure out what those x-intercepts would be, or solutions. It looks like one of our solutions would be 2, and over on this side, if it's negative 3, another x-intercept or root would end up being negative 1. Trying to pull that all together, so if we were to graph this, 1, 2, 3, 1, 2, 3, just a quick sketch, I would have an x-intercept of negative 1, and I would have an x-intercept of 2, and my parabola would be looking something like that. I'm going to do 2 examples of factoring. Again, this should be review. Make sure you are not factoring, guys, until it is set equal to, hopefully you're saying 0. Equal to 0. Okay, so my equation, my quadratic here really needs to be this. Now, this can be factored pretty quickly, so I'm not going to use my formula here. I'm just going to factor instead. I'm going to set up my ACB table. Here's A, here's B, here's C. Again, I'm going through this kind of fast because this should be review. If you need other examples, look back at the e-learning lessons before spring break. 4 times 5 gets me to 20, and that adds to 9. I'm going to factor by grouping, so I've got 4x squared plus 4x plus 5x plus 5 is equal to 0. Remember that this 9x got replaced with these 2 numbers, so everything in green is actually the same thing. We're just writing it in a different way. I'm going to go ahead and split this up into 2 sets of parentheses. And I'm looking for my GCF. The GCF in this first set would be 4x. Making sure I'm staying organized, I'm going to go ahead and label that. When I divide, I'm left with x plus 1. My GCF of the second set is a positive 5. Leaving me with this. Oh, let's stay organized. Here's my GCF. My parentheses match. That is awesome. Okay, I'm talking about these. That's what I want. So I can go ahead and put my GCFs together. 4x plus 5. And x plus 1 is equal to 0. But I want to know what those x-intercepts are. Where are we crossing on the graph? What are my roots? So again, I'm going to go ahead and split this up into 2 different problems. 4x plus 5 could be equal to 0, or x plus 1 could be equal to 0. When you solve it, because again, I'm going through this kind of fast because you've already seen it, we get negative 5/4. And x could be negative 1. Those are my roots. Those are my x-intercepts. Last example. Okay, I have a b term, so I can't use square roots here. I also don't have a c term. But what I do have here, and it's set equal to 0, so that's good, is I do already have a GCF. Okay, has GCF. Both of these terms have an x in common. So staying organized, here's my GCF. I'm going to go factor that out first, because if I factor that out, I'm left with ultimately 2 sets of parentheses, just like what we had over here. So x could be equal to 0, or I could do x plus 5 is equal to 0, which when I solve I end up with -5. Quick sketch again, trying to pull it all together. If you were to solve this by graphing or typed this equation into Desmos, you would have a graph looking something like this, where it crosses at -5 and it crosses at 0. Practice this, guys. We're just pulling everything together. Good luck. Let me know if you have any